Thank you for that welcome. Hi all. So I'll be talking about generative AI, large language model, how you can use to analyze XBRL data, and also touch upon many of the topics that this panel has discussed. Okay, large language model seems very fascinating in what it can do. So this curiosity led us to explore how LLMs can be leveraged for analyzing XBRL data. Through a series of experiments, we discovered that structured data with structured metadata gives you more insightful, accurate, and trustworthy analysis as compared to unstructured data in off-the-shelf LLMs. Okay. So in today's presentation, I'll be covering a few experiments that demonstrate the utility of taxonomy combined with structured data for enhanced analysis, how LLMs can be used as QA mechanisms for taxonomy authors, and new ways of looking at taxonomy. These are experiments just scratching the surface, but the hope here is to push you to think in that direction of using these new age technologies. Okay. I'll start with the conventional dashboard. This was created from ESEF reports on filing.xbrl.org. The inline XBRL reports were converted into XBRL JSON. Why XBRL JSON? Because that is a format understood by third-party analytical tool BI tools easily. So those JSON documents were consolidated, uploaded to Tableau, a BI tool, to create this dashboard. Now, a dashboard like this is excellent for monitoring, for identifying patterns. But with LLM, we can go beyond the capabilities of what this traditional dashboards has to offer. Let's discuss that. Okay, I'll start with a recap of experiments that I did earlier this year and then go on to sharing the new experiments. Okay. This one analyzes going concern disclosures. Now, here I had looked at going concern disclosures from 300 ESEF reports. Okay, when I say ESEF reports, again, the inline XBRL reports were converted to XBRL JSON, and from the XBRL JSON report, the going concern narrative texts were extracted and given to ChatGPT. So once they were given, I had asked ChatGPT to calculate the TF-IDF score for every disclosure. What is that score? It is a numeric score that considers number of words used, how rare the words are, and how frequent the words are within the sample. So analyzing that score, one can spot the common disclosure, common standard disclosure, like this one within the sample, and spot outlier disclosure which stand out because of their unusual wordings or structure. So this example demonstrates how with simple English query, you can spot unique disclosures which might be of interest to regulators and other users. Next one looks at sustainability disclosure. So here I had used the Indian Sustainability XBRL reports, BRSR, that what Dr. Mitra had explained in the morning. Okay, I had extracted this disclosure relating to adaptation and mitigation plan reported by the companies for all the risks that they have identified. Again, this extraction was from XBRL JSON data converted from the original XBRL report. So once that data was extracted, I asked ChatGPT to assess for objectivity in these adaptation and mitigation plan. It understood the query. It said that, okay, I'll be looking for specific quantifiable actions, timelines, targets in the disclosure and classify the disclosure as subjective or objective. So this is an example, few examples of that classification. Like you see here, it did a decent job. So disclosure that lacked quantifiable measure, it classified as subjective disclosure. Now this kind of analysis is very helpful to detect potential hints of greenwashing, which could be of interest to regulators, analysts, and investors. Okay, now next what we are going to do is we are going to do the same test using a single PDF report. So here I had uploaded the BRSR report in PDF and asked it to test for objectivity for the same disclosure, the adoption and mitigation plan. It did answer correctly, but the results also included conclusions from the adjacent column. So what we see here is search in PDF using LLM are often influenced by contents present elsewhere in the report, impacting the clarity. So when you use XBRL data for analysis, it provides a more targeted input, just ensuring a more accurate output and results. Okay, both this going concern disclosure and this sustainability example proves that how with structured data and LLM, using simple English language query, one can derive valuable insights pretty easily. I think that answers one of the concerns that Beyond had, for business users who are not tech savvy, not very efficient with coding, these kind of queries can be really helpful for them. Next, we'll look at examples of using taxonomy relationship in analysis. Okay. Here in this sample, I wanted to understand how gross profit calculations are reported across companies. Now, how do we understand gross profit calculation? It is revenue minus cost of sales. Now, let's see how companies have reported them. Okay, before that, I had looked at 350 ESEF reports, their gross profit calculations. So the JSON taxonomy model in the inline XBRL viewer on filings.xbrl.org was used to extract the calculation relationships and then fed to ChatGPT. So interestingly, the sample revealed that there were 62 different ways of calculating gross profit across those 350 companies. This is a word cloud of those components of gross profit. We find the usual suspects commonly occurring, like cost of sales, revenue from contract with customers, but there are also many unusual elements both from the standard taxonomy and the extended taxonomy. Let's understand this further. Okay, next I asked it to list few rare IFRS elements used in the gross profit calculation. Now you can see distribution cost, impairments. These are not unusual when you look at income statement, but what stands out is though they being included in the gross profit calculation. Now one might want to look at those reports to understand further. Okay, these are some reports. Does this work? Okay, this first example here on top left, they had used impairments in gross profit calculation. This one on to the left bottom had used crypto assets fair value valuation in the gross profit calculation. This is an example of bank which has used a lot of components in the gross profit calculation. Seems like a tagging error for me. Okay, so what this example demonstrates is how taxonomy relationships helps find unusual subtotal components, identify peculiar disclosures or potential tagging errors. Now let's do the same test using a PDF report. So here I had uploaded an annual report in PDF format and asked GPT to tell me the gross profit calculation. First, it replied from its general knowledge, then it corrected it, all good. Then I asked it to show me a breakdown of profit calculations. Okay, what it did was, in the answer, it had mixed values from the non-GAAP measures present elsewhere in the report. So on the right, you see an extract of non-GAAP reconciliation, and here ChatGPT had taken some of the values from that report. So you see here how extracting from PDF can be not much reliable. So having taxonomy relationship is still a reliable approach as compared to extracting data relationships from PDFs. Okay, next we'll look at next we'll look at utility of taxonomy references in search. In a typical sustainability PDF report, the disclosure, the underlying disclosure is linked with a metric using an index like this. So you'll know which page to look at for that specific metric. So this kind of cross-linking is helpful for us humans to understand and also for LLM. But sometimes these cross-references are pretty broad. They might not necessarily lead you to the specific disclosure. Let me give you an example. Okay, this is an extract from the PDF report which says that employee hours worked percentage billable is found on page 71. So I have given this PDF to ChatGPT and asked it to get those numbers. So first it has, it was able to get numbers for employees hours worked, and then it smartly said that the percentage billable thing is available on page 71. Then I asked it, can you get me the value for percentage billable? It said, oh, no, the company has not disclosed it. So this is an example of a PDF reference, a PDF index that does not necessarily lead you to the disclosure in the report. This is example from another report where this specific metric, monetary loss as a result of legal proceedings associated with product safety, okay. So that one, it says that it is available on page 61, but LLM cannot find it, and of course it is not disclosed in the PDF. Now let's do the same search using XBRL data and taxonomy. Okay, in sustainability disclosures, the reporting concepts always specifies the underlying metric as metadata in references. So searching for that metadata, you will be reliably able to pull those values reported against it because the fact is linked to the specific metric using the reporting concept. Okay, let me give you an example of that. So here I had used the sample ERSR report. The facts and the taxonomy model in the inline XBRL viewer were given to ChatGPT. So here I'm asking it to list all the facts that have been disclosed against this requirement defined in paragraph 63, subparagraph C, and section E18. It easily lists all the facts that has the concept with this metadata. Now that was very straightforward for ChatGPT to do because the metric is linked to the concept is linked to the fact. So this is an example how the structured metadata in the taxonomy provides a more reliable link to the disclosure rather than the broadly constructed indexes on PDF. Okay, next we'll look at new ways of interacting with taxonomy. Label construction, that's often the most laborious part of doing a taxonomy. It is also challenging because you cannot write automated rules to say, are my labels concise, are my labels clear, consistent, but LLMs can help here. I had given a list of standard labels in a spreadsheet dump to ChatGPT, sorry, and then asked it to find some redundant terms. So it came out with saying that, phrases like number of, total of, amount of, reporting periods, and filler words like respect to, regarding seems to be redundant. Now this provides clue for taxonomy authors to might be refine, optimize their label. Next one is same again, finding patterns in a set of elements that follow that belong to some category. So here I said look for patterns in label that use the word value chain. So one of the observations that it returned was, often it is frequented with the term upstream and downstream. Now, a taxonomy author might want to consider to move the words upstream and downstream to documentation label and make the standard label more concise. Similarly, you can also find patterns, say, for percentage elements and see if the construction is more consistent. So simple queries like this help taxonomy authors to redefine, revisit their label construction. LLMs can also be used as a QA mechanism if you want to run quick on-the-fly queries, like you want to check if the presentation tree starts with abstracts. So, you can just write an English query, give the model to taxonomy, and give the model to ChatGPT, and it will let you know. Okay. Next, we'll look this interpretation of formula rules. Now, formula rules are very powerful to ensure data quality, but often the criticism has been that it is challenging for business users to interpret that. XF, which is the text-based formula language, greatly simplifies the syntax, but it still seems code-heavy. Now, LLMs are particularly useful to understand codes. Now, let's see, how LLM can help here. So here I had given XF, the XF formula files to Google Gemini and asked it to understand the pattern. So it kind of nicely summarized it. It understood how it works, which was impressive. It understood the structure, the pattern of it. So next I asked it to explain a specific rule, value assertion, which included calculation of public interest score. It very well summarized, gave a breakdown of all variables used in the formula, and also explained the text expression in a manner business users will understand without reading the code, which was quite impressive, if you ask me. So you could use LLM to provide a human interpretation of formula rules in taxonomy tools. So that's a food for thought. Next, a new way to search taxonomy. We've always viewed taxonomy in hierarchies. When we look at taxonomies, when we search for an element, we need to go through the hierarchy to understand the context. So what if LLM can enhance this experience? Okay, here I had given ESR's taxonomy, the model in the inline document, the taxonomy model in the inline viewer to ChatGPT, and asked it to list all disclosure requirements pertaining to transition plan. It did a good job. It kind of listed all the concepts and gave a nice summary, I think, which business users will appreciate. So this is again food for thought to rethink taxonomy navigation and search with LLM. Okay, this is a technical side note, XBRL JSON. ChatGPT understands XBRL JSON very well, so if you want to experiment analyzing XBRL data in ChatGPT, Google Gemini, convert the conventional XBRL report into XBRL JSON, because then it makes it much easier to query the data. The examples where I used taxonomy, the extracts were either from the model within the inline XBRL viewer or a spreadsheet dump. What will enhance this experience of working in LLM with taxonomy is having the standard taxonomy OIM model, which we'll have soon. Okay, I think with that I come to the conclusion of experiments that I wanted to share. So what are the key takeaways? Structured data beats unstructured data. When you combine structured data with structured metadata, the level of insight significantly raise. Now, PDFs are less preferred for data analysis because they have lower extraction accuracy, will need manual checks. There's often pre-processing, might lack scalability. PDFs also provide limited insights into data relationship and links to the underlying regulation. But most importantly, structured data in regulatory program carries the approval of companies' judgment and perspective, unlike PDF, which applies its own interpretation. Okay. So, what a call to action. You know, these are experiments trying to push new ways of thinking. I should admit this is not an academic study, neither I am an expert, so that's a disclaimer. Having said that, it is worthwhile for everyone to explore LLMs in what you are doing. So regulators, software vendors, accountants can use LLM to enhance disclosure, quality of disclosure, the consistency of disclosure, while deriving value through analysis. So yeah, that's it. Okay, my legal slide. All that I've presented are my own opinion and does not represent the view of XBRL International or its governing board. Thank you.
Thank you. Any question? Yes. Okay.
Start here. Hi, I just have a question based on the nice presentation, Revathy. Can LLM be used to create taxonomy?
I think we could explore it. I mean, my interactions with LLM, it's fascinating. You know, you still can create that. I think Bjorn was saying, you know, he had tried to reverse engineer it, gave it a PDF, and tried to create a XBRL document. I think, yeah, why not? Yeah, the answer is why not? Yes. Yeah.
Absolutely. Okay.
And any other questions? Yes.
Okay. As we see from your presentation, so you said that the AA has some limitations in reading the PDF documents, correct? How about the XBRL or IXBRL reports prepared from PDF as a source? Because AA is something works based on how we train it and the amount of data that we are feeding in to train it, correct? Okay. So let's say, for example, for ESCF, we have a bunch of data source. Like you have the IXBRL reports that are prepared from different tools. Okay, so they'll have different structures basically. So how do you think whether AI will have a problem in reading and understanding all these reports?
Okay, so when I said limitations of PDF, it does not mean LLMs cannot read PDF. The overarching message here is you still need manual intervention.
Right.
If you're using say AI for tagging, you would need still someone to go through the tags and ensure that it is tagged properly. So it is not saying that you do not use these tools, but if you want, this is more about using PDF for your data analysis. What is preferred. This is a comparative analysis. When you have structured data and PDF data, of course, structured data will give you more accurate results than PDF data.
Yeah, so my question was like the structured data that are prepared using the PDF as a source.
That doesn't matter. It doesn't matter. Once it is structured data, it doesn't matter from where it came. Does it matter? I mean, it could come from your PDF or Excel.
Okay, thank you.
Yes.
I can also just speak to that.
Yeah.
Yes,
Okay.
absolutely. Yes.
Very interesting presentation. Always really nice to see these things applied in practice. More that turns
Thank
out.
you.
So the organization I work for, we deal with large questionnaires, basically.
Okay.
It's not tagged in XBRL.
mean,
What they deal with is a questionnaire, right? So each answer will have a question. Is that enough structure to harvest the analytical power of AI?
I think it also depends on what you want to extract from those things. If you have a question and answer, that should be a good structure. If it is going to be a block of text with
A lot of free text.
then it becomes difficult. There's some kind of structuring required. Say you want to have insights from question 10. How do you identify that? Unless you say this is answer for question 10, then it makes more sense and the results will be more reliable. Some kind of structuring, yes, of course, is better.
Yeah.
So excellent presentation, everything.
Thank you.
I love the examples. So with regard to the models that you used, did you basically only use ChatGPT?
ChatGPT and Google Gemini. And I did not train them, these were off the shelf models. Yeah.
So the PDFs weren't run through. Did you try running through something else before doing Gemini on it?
No, these were PDF directly loaded to and you start asking it questions. Yeah.
Thank you. Is that the end of the question? No? I think one of the most important message from this presentation was the value of taxonomy. Okay. And of course, ChatGPT can read, and AI can read the plain text. And but we have taxonomy. That is the precise definition of the data structure, and also individual data's meaning and the relation we share. And in the afternoon, Mark, maybe you're talking about that. And then you mentioned about the difficulty for the LLM to understand linked bases and so on. If we can overcome that issue, then we can obtain real value of XBRL for data analytics. I think that will be.
Yeah, I think the taxonomy OIM effort is all about modernizing and simplifying the taxonomy representation in a format that LLMs can understand. Yes.
Okay. So, any more questions or comments? Okay.
Thank you.
So,